Alright guys, what we just created were these two graphs, and the big one in this unit is called the absolute value function. Okay? The absolute value function looks like this. And basically we just had a couple of volunteers create this graph from a position that they were away from this wall. Okay? So we could say that they started at 8 feet away from the wall and they came back to 8 feet away from the wall. As they approached the wall, they reached 0 feet away from the wall. Okay? Now during this time, during this first interval, as they were approaching the wall, I'm telling you that there was a negative velocity. And the negative velocity means it was below the x-axis. Okay? So in respect to this wall, they had a negative velocity. As they moved away, it became a positive velocity. That's why it's above the x-axis. Okay, so if I were to tell you that this is the origin, and then I were to ask you, what kind of slope does this line right here look like it has? What would you say? Just y equals x. Okay? So this right here, it looks like y is equal to x. And what do you think this looks like? Y equals negative x. You with me? So y is equal to negative x would look like this. Now this is all referencing our y equals mx plus b. Okay? Real quick, what you're about to see and recognize is the importance of the number that's in front of the x. What number, what slope is this one? 1. And what slope is this? Negative 1. You with me? So slope is big in this respect. As I'm approaching the wall, I have a negative 1 slope. I have a negative velocity. It's like something falling down, something moving to the left, or if you're driving in your car, it's like moving backwards. Now I know the way they were doing this, they were moving forward, but it had a negative velocity. But I want you to imagine the only way that that would work is if this was facing the wall. So they couldn't do it this way because it would be totally different. It would register across that wall. Actually, it'd probably register across some of you. Okay? All right. But nonetheless, thank you. And then go ahead, grab the calculator on my desk, please. As the students were approaching the wall, they had a negative velocity. But what did they have the entire time that was positive? Think about that. That's the big part of today's stuff. What was positive the entire time? The distance. The distance from the wall was positive until no one hit it, but if they had, it would have been what? 0, and then it was back to positive distance. You with me? So a huge idea of absolute value is that it's an absolute value distance. In other words, it's never a negative distance. Can you cut for me 5 feet of rope? Yeah. Could you cut for me 10 feet of rope? Yes. But can you cut for me negative 3 feet of rope? No. So absolute value is measuring all positive values because it's an absolute value distance. Okay? The best way that I can tell you is this. It's the distance from 0. Okay? Here we go. Let's say here's 0, and I picked a number 5. You with me? This value, the absolute value, is the jump away from 0. So if I go from 0 to 5, how far is it? 5. 5 feet of rope. You with me? What if I went to a negative 5? How far is this distance? It's still 5. You with me? I still get the same positive 5 feet of rope. So fundamentally, when I'm talking about position, I can take the absolute value of 5 and I will get 5. I can also take the absolute value of a negative 5 and what do I get? 5. So a good rule is that it will make anything positive. You with me? But that's not how I want you to remember it. I want you to remember that it represents the distance from 0. So when we start getting to more complex transformations and stuff, you're understanding what's going on. Okay? The other part was velocity. Okay? And from negative infinity all the way to 0, the slope was negative 1 on this parent function. And from 0 all the way to infinity, the slope was a positive 1. You with me? What was the slope at 0? There's no slope. You with me? So if I have a negative x, negative 1, and I have a positive x, positive 1, right here we call these things cusps, basically a corner. You can't see what the slope is because it's neither 1 or negative 1. So we just say it's undefined. It's not a slope. Okay? Yeah?
So the interval notation will still be parentheses or will be bracket because like it touches on the 0.
So it's going to be a parentheses because at 0 it's not 1. Because that's a really good question. Do you hear what he's saying? Does there belong a bracket at 0 on any one of these? No, because you can't fail the vertical line test per se with slope. If I told you at 0, what's the slope? Some of you might say 1. Some of you might say negative 1. But you're both not correct because it's neither 1. You with me? Okay. And that's like calculus stuff. If you can kind of start getting into that and understanding what that's talking about, that's all calculus interpretation. Any questions so far? Okay, so distance-wise, the absolute value will always be what? Positive. And it's always representing the distance away from what number? 0. Okay? Alright. So let's go ahead and go to our notes. Alright, so let's go ahead and begin. The absolute value parent function, the way it begins is f of x is equal to the absolute value of x. Okay? So again, the big thing, these are representing the absolute value representation, but also saying that that's the distance away from 0. Okay? Alright, we'll get to that here in just a bit. Alright, so if I'm looking at these values, and let's say I plugged in negative 3 right here for x, what would I get as an answer? 3. Okay? So I'm going to get a positive 3. That means f of x is equal to what? 3. Therefore, my point is at negative 3, 3. So left 3, up 3. There's where I would put a point. Okay? Plugging now this 2 up here where x goes. What do I get, guys? 2. The f of x answer would equal 2. And therefore, my point is what? Negative 2 and 2. We're going to go ahead and start graphing these. So negative 2 and 2. So let's jump to 0. Let's plug 0 in. What would I get? 0. Is 0 positive or 0 negative? Neither. Okay, so 0 will always be 0. But nonetheless, the absolute value is always going to spit out a what value? Positive. A positive. So, but don't interpret 0 as positive. Okay? 0, 0. So yes, f of x would equal 0. Otherwise, 0, 0. Guys, just a reminder, all we're doing is an XY chart. So these are x's, and these are y values, and we're just going to put them as a point of where they're located. Okay? Alright, so negative 1, let's go, Brianna. What would negative 1 become? 1. And f of x is? 1. And my point is what? Perfect. Tyson, what would positive 1 give me? 1 all the way, right? And then what's my point? 1 comma 1. Catherine, how about positive 2? 2, and it's just 2. So this is fairly easy, right? And then you just go and you put all the numbers, right? And then I'd get 3, 3, and the point would be 3, 3. So we go negative 1, 1. Then we'll go 0, 0. We'll go 1, 1, 2, 2, and 3, 3. Because we were graphing these points right here on the graph. And then from there, we're just going to piece them all together and see what kind of graph we see. And you see something that looks like that. Okay, so the absolute value graph, again, will look like this. Cool? Now, this slope from 0 to infinity, what did we say it was? 1. And then this slope was what? Negative 1. And this is from negative infinity all the way to 0. And just for extra practice, guys, how do we write these intervals in algebraic notation? So x is greater, so that's set notation. The more basic form is just the inequalities, okay? So this would be x is what? Greater than 0, right? So please don't do this. I didn't take off, but I will take off this unit if you're still doing that. Don't write it like this, okay? Just write the x is greater than 0 piece, or if you want to put 0 is less than x, that's fine. I didn't take off this test, but I will going forward if you are still writing this stuff, that less than infinity stuff, okay? So make sure to refine that for next test for sure. Okay, what would this one be over here? X is less than 0. Perfect. And then one more last thing. What did we say the slope is at x equals 0? There is no slope, right? It does not exist. So we'll say just, it's not really undefined. Because an undefined slope looks like a vertical line. You with me? This is more like it just does not exist. Okay? So we'll just put D and E for now. Are we good? Okay. So let's keep going. And we kind of already showed the domain. So my graph, I'm going to just do a quick sketch here. Look like this. And let's go with, to review, what's the domain of what you see right there? To what? To infinity. You could put negative infinity to infinity. This is interval notation. Riley, what else could you put? All real numbers. So you could say all real numbers like this. And if you went beast mode and went all the way to set notation, Thomas, what would that be?
Not so much the second, but doesn't imply that you're also passing on 0 even though you told us the parentheses are on 0?
So, no, this is including 0.
Oh, okay.
So, listen, this is a good question. The parentheses for 0 was not for the domain. That's not what we were talking about. We were talking about the slope. What was the slope? Now we're saying, where does it exist? Where does the graph exist? And it exists everywhere, including 0. You with me? So we will put x such that x is an element of all the real numbers. Questions? Please ask me if you have. Okay, here we go. Corbin, what's the range of this graph?
0 to
Perfect. 0 to infinity. We know this is parentheses. Corbin, what's the, is it bracket or parentheses at 0?
That's a bracket.
It's a bracket. These are important, guys. Parentheses and brackets are huge right now because you're learning parent functions. Okay? What's another way that we could have written this? Because right now we did it in interval notation. What's another way we could have, Skylar, what's another way we could have written the range? Close. Y is greater than or equal to 0, because I am touching the x-axis. I exist at the x-axis. It's not like I have a hole in the graph there. No, it's not a hole. It actually comes to a point that is filled in. Okay, so up here that would be equivalent to like negative infinity less than x less than infinity, stuff like that. Okay? But again, this is the interval notation, more preferred. And you could also just do all real numbers. So the interval notation with algebraic, that's pretty much it. There's no other way that we could really write this out unless it's set notation. And that would be the set of all y such that y is greater than or equal to 0. Easy? Okay. X-intercepts. Michael, what do you think whenever you see x-intercepts, what do you think I hope you immediately think about? Yeah. Let me help you out. Something equals 0. Not 0 equals 0. When y equals 0. Okay? So y is equal to 0. Like a point, it would look like that. And the x-intercepts that you're about to list are those. Vice versa, Sarah, what do you think I want you thinking immediately when you see y-intercepts? X equals 0. So guys, quiz, test, CFA doesn't matter. When you see x-intercepts, immediately think y equals 0. When you see y-intercepts, immediately think x is equal to 0. And the y-intercepts, whoops, are those values right there. Okay? Santiago, what is the x-intercept that you see in this parent function?
0.
0. So you'll say x equals 0. That's the answer. Okay? If you put this point right here as 0, 0, is this whole thing my answer? Is that my x-intercept, the whole thing? No, it's not. My x-intercept is just that piece right there. Because the x-intercept happens when y is equal to 0. Do you see how I'm highlighting them, though? Okay. So, Nate, let's go to the y-intercepts. What y-intercepts do you see? 0. But we're not just going to put 0. We have to specifically write y equals 0. Okay? Because we're talking about... Okay, let me highlight it. We either write it like this, or we can write it like that, showing that this is the y-intercept. Or, sorry, that's the y-intercept. When x is 0, it will show you what y's value is. Okay? Axis of symmetry. Okay, so let's go with symmetry. Anna, what is axis of symmetry? What do you think it means? Yeah, it's a straight line. She's actually absolutely right. It is a straight line. And symmetry has some kind of symmetric feel to it. In other words, balanced equalness to it. So what would you say?
Is it like the straight line that can cut it?
Yeah, perfect. That's the axis of symmetry. So the axis of symmetry is going to cut this line perfectly in half, and it's going to do it in a vertical way, where it looks like that right there. There's your axis of symmetry. Okay? Owen, what's the equation of that dotted line that I just drew? Perfect. X is equal to 0. Notice it doesn't say y equals mx plus b. It doesn't have a y. Because if it did, it would be diagonal of some sort. You with me? Remember, if it has x and y, then it's going to be diagonal. If it only has y, what is it going to be? Horizontal, yeah. This is horizontal, where it looks like this. And if it only has x, what would it be? vertical. And in this case, we see it's x equals 0. And if it has both, what would it be? Diagonal. It could either have a positive slope or it could have a negative slope. Just a little review-ish with that kind of stuff. Okay, the vertex. The vertex is the point at which this absolute value has no slope and will change directions. You with me? All right. This one we actually give full as x and y. So Brittany, what would that be? It's okay. Try it.
I'm really blank right now.
Oh, it's okay. 0, 0. Yeah, so this is going to be 0, 0. It's the location on the graph where the corner, you can write the tip or corner of the graph. Okay? That's what the vertex means. Okay? Real quick, let's go back to geometry just for a little bit. What shape is that I just drew? A pentagon. N is 5. And if I asked you, how many vertices does this have, what would you say? 5. What does vertices mean? The tips, the corners, the angles. Okay? So a vertex is a singular form of vertices. You with me? Like radius is 1, radii or radiuses, whatever. I'm just making that up. So vertices is plural form for a singular vertex. Okay? So that's what that 0, 0 comes from. All right. Do I have a max or min? Will I have one or the other, or could I have sometimes with this graph, could I have both? What do y'all think? I could have both, but it won't be at the same time. It'll either be a maximum or it'll be a minimum. You with me? So let's think about this. Let's say that this was your bank account, okay? And it was just going down and going down and going down because you're spending like crazy, especially because the holidays are right around the corner. But then you stop spending so much and you start saving again. You with me? Did you just experience a max or a min? A min. Now this is very important what I'm about to say. What's the min? 0. Which of those values is the min? There's only one of them that will represent the min. The y value. That's so subtle but very important, okay? So this will tell you what the minimum value is, and this will tell you what? Not the max. It'll tell you when or where the minimum value occurred. Think of it like time. Sometimes this will say like 5, 0. So it could be a graph that looks like this. At 5 seconds, I experienced a minimum velocity or position of 0. You see what I'm saying, guys? So it's very important that you know this is basically when or where the location is. And this is telling you what is that value. Okay? And in this case, it's going to be a minimum. What kind of graph would I have if I'm experiencing a maximum? You see what I'm saying? What would you do to this graph to make it look like a maximum? You reflect it. Yeah, reflect it across the x-axis, and it would look something like this. And basically you have the top of a mountain. You have a peak. You have a maximum value that just occurred. You with me? And just to see what you think right now, what would be the equation of that? If the original blue one was this, and I'll tell you right now, this red one that I made up, it's actually this. x minus 5. Even though we shifted it to the right, I know we'll learn about that starting tomorrow. What do you think the equation to this one is? Negative absolute value of x. Perfect. Cool? Alright, last but not least, the slope of the sides. That's really the last thing we should learn, but that was the very first thing that I introduced to you, because it's very important. What's the slope of the left side? Negative 1. So we're going to say m is negative 1 on negative infinity all the way to 0. Remember, like we were talking with Thomas, it's not bracket, because the slope at 0 is not negative 1. We good? Alright. Grant, what is the slope to the right? What would you say?
Equals 1 on 0 to infinity.
Perfect. So from 0 to infinity, parentheses on both, like Grant said, the slope would be 1. And last but not least, just so that we know, what's m at? So these are on. On means like intervals. At means at one point. So at x is equal to 0, anyone, what did we say the slope was? Does not exist, right? You could do undefined as well, but we're going to put it does not exist. Because I strictly try to reserve undefined more so for when I'm dividing by 0. Okay? And I'm not dividing by 0 here. It's just it's a cusp. It's called a cusp, the corner. Put that right there. That's already calculus stuff. We good? Alright. So, that's the first one. The notes that you guys grabbed on your way in, they will be due for homework next time. So there's a lot of stuff that we're going to be working on with these graphs, but I want to do a couple of more example problems with you so that you have a solid understanding of what's going on.